Welcome to lesson 12.1. Unit 12 is going to be talking about quadratics and how we look at quadratic functions. So this is just an introduction lesson, and your aim today is that you can describe quadratic functions in standard form by finding the domain and range, by finding the axis of symmetry, the vertex, and the zeros, or also called the x-intercepts. So these are all terms you've heard before in a very earlier unit, and we're going to talk about specifically quadratics today. So we've now studied linear and exponential functions. These functions are relatively simple because they were either always increasing or always decreasing for their entire domains, right? A line is either always going up or it's always going down. Now we're going to start to study other functions, most notably quadratic functions, which are a type of polynomial. Their definition is shown below. So here's the definition of quadratic function, and this is also called standard form. Okay, so this is standard form. Okay. Any function that can be placed in the form y equals ax squared plus bx plus c. This is standard form. You always have to have an x squared, you always have to have an x term, and then you can have a constant at the end. You also have coefficients in front of your x squared, in front of your x, a, and b. Most importantly is that a cannot equal 0, and I'm going to show you why in exercise A. So exercise 1 is going to walk us through some properties of standard form. So let's talk about why it's important for that leading coefficient to be not 0. So let's show an example. Let's say I have y equals 2x squared plus 3x plus 1. This is correct. I can use this as standard form. But what happens if that leading coefficient, now remember leading coefficient is this number right here. What if I change this leading coefficient, that 2, and what if I make it like 0x squared plus 3x plus 1? Well, what does that simplify to? 0 times anything cancels out to 0, so I end up just having 3x plus 1, and this is actually a linear function. So that is why the leading coefficient can't be 0, because they'll turn it into a linear function. So a always has to be a number bigger than 0, or less than 0, it just can't be 0, right? So letter B says, circle the choices below that are quadratic functions. So let's take a look at the first option, y equals x squared minus 3. I have an x squared term and a constant. It's okay that I don't have this term. That's okay. It says b and c can be 0, so this is a quadratic function. As long as I have an x squared term, I'm okay. The next one, y equals x to the third plus 2x squared minus 4. This cannot be a quadratic because I have that. This is called a cubic and not a quadratic, so this is not a quadratic function. The third one, x squared plus the square root of x plus 7, this is not quadratic, okay? And because of that square root, you can't have a square root. And the last one, y equals 10 minus x squared, that is a quadratic. Even though the x squared is not in front, I could always rearrange it so it says y equals negative x squared plus 10. So I can always rearrange the terms and still make it in standard form. Okay? And that brings us to talking about letter C, which is talking about rearranging standard form. So given the quadratic equation, y equals 10 minus 3x squared plus 7x, write in standard form and state the value of the leading coefficient. So standard form, here's standard form, ax squared plus bx plus c. So I'm going to rewrite this so I have my x squared term first. So here's my x squared term, negative 3x squared. The next is my x term. Here's my x term, the 7x, so plus 7x. And finally, I have my constant, the 10. So I'm just rearranging. Okay? So this is standard form. Then it wants me to state the leading coefficient. The leading coefficient is that very first number in front of the x squared, and that number happens to be negative 3. So my leading coefficient is negative 3, and my standard form is negative 3x squared plus 7x plus 10. It's really important you always put it in standard form, okay, for a lot of reasons. Standard form is really, really important. The order matters, okay? I could also, if I wanted to, say a equals negative 3, b equals 7, and c equals 10. because that's my A, B, and my C here. So that's another really important thing, to be able to pull those letters out that stand for those specific numbers. Okay? Letter D says, if f of x equals 2x squared minus 3x plus 1, then find, without using your calculator, the value of f of negative 2. So f of negative 2, remember this notation comes up a lot. This notation means that you plug in the number in the parentheses. So I have f of negative 2, here's my original equation. Instead of x, I'm going to plug in negative 2. And this becomes squared. And then minus 3, and for this x, I'm going to put in negative 2, and then plus 1. So I'm just replacing the x's with negative 2. And now I'm going to simplify. Always do exponents first. Negative 2 squared is 4, and negative 3 times negative 2 is going to give me a positive 6. Keep simplifying. 2 times 4 is 8. And 8 plus 6 plus 1 is 15. Now it asks me what point must lie on the line. Well, this is my x value, and this is my y value. So my point would be negative 2, 15. So that point would lie on that graph. Okay, so these four different exercises are kind of talking about different properties of a quadratic. Okay, ways you can rearrange them, why leading coefficient is important, and how you can plug in x values to find y values and get points to plot on your graph. Okay? Quadratics still behave in similar ways to other functions. Inputs go in, outputs come out. So we have x's are your inputs, outputs are your y's. But they start to behave differently from linear and exponential functions because sometimes outputs repeat. Okay, and it's like a really cool pattern. So exercise 2 is going to talk about the simplest of all quadratic functions, and one you should probably memorize. F of x equals x squared. Okay, x squared is the most common quadratic function, and you're going to see it a lot, so it's important to see that what its points are and kind of memorize the shape. So A says, fill out the table below without using your calculator. So x is negative 3. This first one would be y equals negative 3 squared. What is negative 3 squared? That's 9. Okay, let me see if I can figure out a better way to put the space here. Okay, so let's get my pen. So this would be like saying negative 3 squared. Okay, the next one, negative 2, would be like saying negative 2 squared, which is 4. Then this would say negative 1 squared, which is 1. Then 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So do you see how these repeated themselves? Do you see how I have a 9 here and a 9 here, a 4 here and a 4 here? The only thing that changes are your x values, and the signs are different. So this is going to happen a lot where your x, y values repeat. And let's plot these points so you can see what they look like. So this becomes the point negative 3, 9. This becomes negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And we're going to plot these. So negative 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's my first point. That's this point right here. Then negative 2, 4. That's this point. Negative 1, 1. And 0, 0 is right here. Okay. Now I'm going to go to 1, 1. I'm going to start to see my points going back up. 2, 4 is right here. And 3, 9 is here. So I've plotted all 7 of my points. And it's going to form this curvy shape like this. And this is the shape of x squared. It's a parabola. Okay, notice there's symmetry, and this is something that's really important with a quadratic. This point right here, okay, that point is called your vertex. Okay, it's where the turning point is. There's going to be symmetry down this line, meaning that these points are equidistant from each other. So this is 2 away, that's 2 away. This is 3 away, that's 3 away. Okay, so it has symmetry around the turning point. Okay, Letter C says, what's the range of this function? So that takes us back to an old unit where we have to remember what range is. Range is all possible output values. Remember, our output is our y, so it's all possible y values. Now with a parabola, there's going to be a point where the range will stop. So if I look here, and let me kind of erase a little bit of this. Let me erase this right here. Okay. On my parabola, if I look at my y values, do you see how all of a sudden it stops right here and there's nothing below it? Where I'm putting a question mark, there's no points. That's the bottom of my range. So that means that my y values have to be greater than or equal to 0. I can't have any negative y values in this particular function because it stops right here at the vertex. So my range is y has to be greater than 0. Or you could say from 0 to infinity. You could also say this. Either notation is correct for your range. Okay? So let's put a lot of this stuff together. Quadratic functions can obviously be more complicated than the last example. The last example just had x squared. There was no plus b or a plus c. So let's look at another example that has a b and a c in it. Okay, and it's still going to give the kind of same shape, but it's going to look a little bit different. So here's our new quadratic function, y equals x squared minus 2x minus 8. So that's the quadratic function we're going to talk about. Letter A says, using your calculator, help generate a table and graph this parabola on the grid given. Show a table of values that you use to create the plot. So that's easy. We've got to open up our calculator. Okay, so I have it open here, fortunately. So here's my calculator, and I'm going to make a table of values. So I'm going to go to Menu. Actually, I'm going to hit Control N to get a new. Oh, let me get off of that there. Okay, Control N to get new, just like normal. I'm going to add a graph because I'm going to put in I'm going to type in my equation. So I've got y equals x squared minus 2x minus 8. So I'm going to type in x squared minus 2x minus 8. And I'm going to hit enter on my calculator, and there I'm going to get the picture of what my graph looks like. Okay? Now that doesn't really help me because I need those points. So how do I get the points? Remember, you hit Control plus T to get the table. So I'm going to hit Control T and get my table. So here's my table, and I'm going to, draw it onto here so I can see it a little better. Now, a good rule of thumb is you see my grid right here. I've got negatives and positives in my grid. So I don't want to just do 1, 2, 3, 4, 5. I'm going to have to scroll up in my table and get some negative values. So I'm going to start at this negative 3, 7. So I have negative 3, 7, negative 2, 0, negative 1, negative 5, 0, negative 8. I'm running out of space, so I'm going to continue it over here. 1, negative 9. Let's go down a bit. 2, negative 8, and 3, negative 5. Okay, so I'm going to plot some of these points and see what I get. So the first point, negative 3, 7. So I go over 3, 1, 2, 3, 4, 5, 6, 7. So there's my first point right there. Negative 2, 0. There's another point. Negative 1, negative 5. 1, 2, 3, 4, 5. 0, negative 8, which is down here. 1, negative 9. And now I'm going to start to see a pattern here. 2, negative 8, there's my turning point, because now I'm making points that are going back up. So I'm going to see that I've got symmetry. Now, I know that since my turning point, if I keep going down on my table, since my numbers are repeating itself, I should probably have symmetry here at this point right here. I'm guessing that I've got a point here at 4, 0, and I'm also guessing I have a point here at 5, 7. And so I scroll down here. Does it match? Yep, 4, 0, and 5, 7 because of that symmetry. Okay, now I'm going to connect my lines, make my curve, put my arrows on the end to show that it'll continue going up, and I finish graphing my parabola. Okay, notice it looks similar to my previous graph here. It's still a curve going up. It can also go down too. We'll see that later, but it's still that same shape, and we call this shape a parabola. This is important. Okay, this word is important, parabola. All right, so let's make this full screen again here. Okay, so it's easier to see now that I've got my graph, and I want to answer some questions about the graph. So B says, state the range of this function. The range of my function, again, is my y values. So where's the very bottom of this graph? It's right here at the point, where's my eraser? At the point 1, -9. So this right here is my vertex, or we also call it a turning point. And that's where the start of my range will be. So y has to be greater than or equal to -9, or you can put it in this notation where it goes to infinity, right? Because it's always going to go up forever and ever and ever. Now this is asking, over what domain interval is this function increasing? Increasing means it's going up. And it wants to know where it's going up. Well, if I start from the left, this right here, this is decreasing. This here is now increasing. So the increasing starts at the vertex as well, and it continues to go up forever. So the start of my increasing is at x equals 1. So x equals 1 is where it starts to increase. And then this kind of graph is going to increase forever and ever. So the domain interval is from 1 to infinity. Okay, it's increasing from 1 to infinity. And remember, domain means x values. Range means y values. Okay? And this comes from, I think, lesson unit 5, 5.7 is where domain and range come from. Okay? D, state the coordinates of the parabola's turning point. We've already done that. That's this point right here. This point right here, the big purple dot, that's my vertex, that's my turning point, and it's at 1, -9. This is also known as a minimum. Okay, because it's the lowest point of the parabola. Okay, all this vocab is really important. Things I'm underlining here, vertex, minimum, domain, range, all very important vocabulary. Okay. Letter E says, draw the axis of symmetry. What the heck is an axis of symmetry? Okay, well, an axis of symmetry, I'm going to do it in yellow, is the line that goes straight through the vertex. Okay, so right here is your axis of symmetry. So I'm going to draw it, and it's usually drawn as a dotted line with arrows. So this is your axis of symmetry. Okay, and its equation would be x equals 1. Okay, it's wherever, let me make this in a darker color here, right? This is your axis of symmetry. It's at x equals 1, and it goes through the vertex, and the equation is always x equals the x coordinate of the vertex. Okay, remember that vertical lines are x equal lines. Okay, and finally F, what are my x-intercepts of the function? This is the last vocab we have for this example. The x-intercepts are those places where the line crosses the x-axis. We also call these zeros. So this right here is 1, and this right here is 1, because this is my x-axis. So this is the coordinate 4, 0, and this is the coordinate -2, 0. So when I write my answer, I'd write -2, 0, and 4, 0. Why does this name make sense? Why are they called zeros? Well, because it's where y is 0. That's why they're called zeros, because the y value is 0. Okay? So lots of vocabulary in lesson 12.1, a lot of things to memorize in describing the shape in this graph. Okay, use your calculator to help you graph, and good luck on your fluency, and please do not copy the answer keys from Unit 12, because honestly a lot of this is memorization and the mastery will not be easy. Okay? Oh, I forgot there's one more problem. Alright, well, let's do this one real quick. I didn't realize we had an exercise 4. So in exercise 4 they give us a table. The quadratic function f of x has selected values shown in the table below. What are the coordinates of the turning point? Okay, so when you're looking for a turning point in a table, you're looking for the place where the numbers repeat themselves. So I'm going to look here, and where do the numbers start to repeat? 4, 9, 12, 13, 12, 9, 4. So do you see this 12, 9, 4, and then 12, 9, 4 here? That means that this 13 must be where it starts to turn. So this 2, 13 must be the vertex of the turning point, because it's got these repeating numbers on either side of it. Okay? And if I know the turning point, then I know the range. Okay, it's maximum, this right here, its maximum y value looks to be 13. And all the other y values are less than that. So I'm going to infer that that means that all the y values have to be less than or equal to 13. Or I can say it goes from -infinity to 13. Either way, to write your range notation. Okay, sorry I forgot that last problem. There'll probably be a fluency question or mastery question involved there. So, good luck.